Yeah, welcome back everybody. Let's solve number 2 of these questions very quickly. Let's start, and that's 2a. Let E be a set with elements 1 to 10. That's the universal set. The universal set E has elements 1, 2, 3, 4 up to 10, 5, 6, 7, 8, 9, 10. And set A has elements which are odd numbers up to 9, and those will be 1, 3, 5, 7, 9. Set B has elements which are numbers less than 7, and those are 1, 2, 3, 4, 5, 6. Now write out the members of the following sets. Roman figure 1, the members of a set A complement. The members of a set A complement are the numbers which are in the universal set but not in A, and those are 2, 4, 6, 8, and 10. 2, 4, 6, 8, 10. Those are the elements which are in the universal set but not in A, so they are going to be the elements of the set A complement. Now the members of the set Roman figure 2 B complement, those are elements which are in the universal set but not in B, and those are, we have 1, 2, 3, 4, 5, 6. So the members of the set B complement will be 7, 8, 9, 10. Those are elements which are in the universal set but not in B. Roman figure 3, the elements of the set A union B, that's a combination of A and B, so we can write all the elements of A first, and those are 1, 3, 5, 7, 9. And now we write the elements of B that are not already in A, and that will be 2, 4, 6. That's how to combine two sets, 2, 4, and 6. So A union B, the elements of A union B are 1, 3, 5, 7, 9, 2, 4, 6. Roman figure 4, the elements of the set A intersection B, elements of members, they mean the same thing. A intersection B, those are elements which are common to both A and B. 1 is in A, 1 is in B, 3 is in A, 3 is in B, 5 is in A, and 5 is in B, and that's all. So the elements of the set A intersection B will be 1, 3, 5. Now what's next? Roman figure 5, the elements of a set A complement intersection B complement. Those are elements which are common to the sets A complement and B complement. What are they? 2 is in A but it's not in B, 4 is in A but it's not in B, 6 is in A, 2 is in A but not in B, 4 is in A but not in B, 6 is in, 2 is in A complement but not in B, 4 is in A complement but not in B complement, 2 is in A complement but not in B complement, 4 is in A complement but not in B complement, 6 is in A complement but not in B complement, 8 is in A complement and it's also in B complement, 10 is in A complement and it's also in B complement. So the elements of the set A complement intersection B complement are 8 and 10. Those are the members of the set A complement intersection B complement. Now straight we go to 2b. We go to question 2b, and that says if X, the set X and Y, are subsets of the universal set E, where the universal set E remains a set with elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. List the members of the following subset of E. Question Roman figure 1. The set X such that the set X with element X such that X minus 2 is less than or equal to 2. That's the first set whose elements they want us to list. We need to write out those elements. Yeah, we're just going to write out the elements. And here what we do is we find each of the numbers in E, which when 2 is subtracted from it will give a result that is less than or equal to 2. I go over that again. We find the numbers in the set, in the universal set E, which will give a result that is less than 2 or equal to 2 when 2 is subtracted from it. In other words, I'm going to substitute each of these elements for X in the expression X minus 2, and if I get the result that is equal to 2 or less than 2, then that element I substituted for X is going to be a member of the set big X. Yeah, that's what we do now. So that's what we do next, and that's how we go. So that means the set X will have elements. Let's check. Let's start with 1. 1 minus 2 is equal to minus 1. Minus 1 is less than 2, but it is minus 1 is less than 2, so that means 1 is a member of the set X because it gave us a result that is less than 2. Now 2 minus 2 is equal to 0, and that's also less than 2, so that means this 2 is also a member of the set X because it gave us a result that is less than or equal to 2. Let's go to 3. 3 minus 2 is equal to 1, and 1 is also less than 2. The condition is that the result must either be less than 2 or equal to 2. So since the result is less than 2 here, that means 3 is also an element of the set X. Now the next one, let's check 4. 4 minus 2 equals 2. This one is equal to 2, and the condition is that it must either be less than 2 or equal to 2. That simply means that 4 is also an element of the set X. What else? 5 minus 2 is equal to 3. 3 is bigger than 2, so it doesn't satisfy the condition less than 2 or equal. It doesn't satisfy the condition less than 2 or equal to 2. So that means 5 is not a member of the set X. If we check 6 minus 2 is also equal to 4, which is neither less than 2 nor equal to 2. So 6 cannot be a member of the set X. We go to 7. 7 minus 2 is equal to 5. 5 does not satisfy the condition less than 2 or equal to 2. So 7 cannot be a member of the set X. 8 minus 2 is 6. 6 is not less than 2. 6 doesn't satisfy the condition less than 2 or equal to 2. So that means 8 is also not a member of the set X. 9 minus 2 is equal to 7. The result 7 does not satisfy the condition less than 2 or equal to 2. So that means 9 is not a member of the set X. Now to 10. 10 minus 2 is equal to 8. And 8 doesn't satisfy the condition less than 2 or equal to 2. That simply means that 10 is not a member of the set X. So the members of the set X are 1, 2, 3, 4. Now to Roman figure 2. List the members of the set Y with element Y such that 3y minus 2 is greater than or equal to 19. So we're going to do the same. We check which of the elements of the set E will give us a result that is greater than or equal to 19 when we substitute it for y in 3y minus 2. And there we go. Let's see that 1. 3y minus 2 means 3 times 1 minus 2. That's equal to 1. And this is not greater than or equal to 19. So that means 1 is not an element of y. We go to 2. 3 times 2 minus 2. I hope I did the right thing here. This is supposed to be 3 times 1 minus 2. That's 3 minus 2, 1. And 1 is not greater than or equal to 19. That means the element 1 is not a member of the set y. We go to 2. 3 times 2 minus 2 is 6 minus 2, which is 4. And 4 is not greater than or equal to 19. That means 2 is not a member of the set y. We go to 3. 3 times 3 minus 2 equals 7. And 7 is not greater than or equal to 19. That means 3. This 3 is not an element of a set y. We go to 4. 3 times 4 minus 2 is equal to, that's 12 minus 2, which is 10. 10 is not greater than or equal to 19. So 4 is not an element of the set y. We go to 5. 3 times 5 minus 2, that's 15 minus 2, which is 13. 13 is not greater than or equal to 19. So 5 is not an element of the set y. We go to 6. 3 times 6 minus 2 is 18 minus 2, which is 16. 16 is not greater than or equal to 19. That means 6 is not an element of the set y. We go to 7. 3 times 7 minus 2 equals, that's 21 minus 2, which is 19. So 19 is equal to, 19 satisfies the condition greater than 19 or equal to 19. So that means 7 is an element of the set y. So the first element of the set y is 7. Now we go to 8. 3 times 8 minus 2 equals 22. That's 22, and 22 satisfies the condition greater than or equal to 19. That means 8 is an element of the set y. We go to 19. We go to 9 rather. 3 times 9 minus 2 equals 27 minus 2, that's 25. And 25 satisfies the condition greater than or equal to 19. That means 9 is an element of the set y. The next is 10. 3 times 10 minus 2 equals, that's 30 minus 2, which is 28. And 28 satisfies the condition greater than or equal to 19. That therefore means that 10 is an element of the set y. So the elements of the set y are 7, 8, 9, 10. And question Roman figure 2b Roman figure 3 is find the elements of the set, the elements of the complement of the union of x and y. But we need to find x union y first. The set x union y has elements 1, 2. We combine x and y. We write all the elements of the set x first, and then write the ones that are in y but not in x. 7, 8, 9, 10. So this is a set x union y. That's a set x union y. So the complement of x union y will be the elements that are in the universal set but not in x union y. 1, 2, 3, 4, 7, 8, 9, 10. So the ones that are in the universal but not in x union y, 1 is in y, 1 is in the universal set, 2 is in y, 1 is in x union y, it's also in the universal set E. 2 is in x union y, it's also in the universal set E. 3 is in x union y, it's also in the universal set E. 4 is in x union y, it's also in the universal set E. 7 is in x union y, it's also in the universal set E. 8 is in x union y, it's also in the universal set E. 9 is in x union y, it's also in the universal set E. 10 is in x union y, it's also in the universal set E. So the only elements that are in the universal set E but not in x union y are 5 and 6. And those are the elements of the set those are the elements of the complement of the set X union Y. Yes, so the elements of a set which is a complement of X union Y are 5 and 6. Yeah, that's very correct, and that's it. Very, very simply. It looks a bit tricky, but it's simple if you take your time and make sure you don't make mistakes. That's gonna be it. Thank you very much, and catch you in the next. Bye bye.